So in 2005, when I was looking for my next job, I contacted my previous boss who had been at Google. And then I read about a new Yahoo research lab that was being opened. And I got both the opportunities by nurturing my network and by keeping myself informed. This is what LinkedIn does for every professional in the world. It's a digital platform to help you find opportunities. And all you have to do is come to the platform, tell us what you're excited about, what you're passionate about, what is your work history. And then we have automated AI algorithms harnessing all this data and infusing intelligence to connect talent with opportunity. Right? And how do we do that? Right? So we do that by helping you connect to the right people through people you may know. Once you're connected to the people, we help you consume the right content on the news feed. We help you find the next job that you should be taking. We help you take the right courses to upskill yourself. We help you source the right candidates through AI algorithm. We help you market to the right people through our sponsored updates. We help you contact the right decision makers so that you can sell your product efficiently. So AI is everywhere at LinkedIn, and the scale of this is also staggering. We process petabytes of data. We run machine learning models that have billions of parameters. We run more than 200 A/B experiments to kind of keep innovating at scale. And we have massive graph data as well that is powering this AI that we have in our ecosystem. Right, so I'm going to talk about, so today we are going to talk about how we infusing intelligence everywhere at LinkedIn, and then Shouvik is going to tell you how we are accelerating the innovation speed of AI. And all of that is done by using the foundation of trust, which again Shouvik is also going to talk about. Right? So let's talk about intelligence everywhere. How do we do that? Right? As you saw, we have AI across all of LinkedIn. So the first thing is formulating the right problem. And at the high level, if you think of the LinkedIn ecosystem, it is a collection of marketplaces. There is a hiring marketplace, engagement marketplace, advertising marketplace, and so on and so forth. And like in every marketplace, there are actors that are interacting with each other to maximize their utility. And these interactions give rise to massive amounts of data that you can then harness through AI algorithms to improve the relevancy of matchmaking. And that's how you improve the ecosystem on a continuous basis. So this AI-powered matchmaking is what is key to the success of the entire platform. That's a beautiful slide, but not very important. So, and again, in order to do this, you also need a scalable and robust infrastructure. Right? So you cannot do AI without having the infrastructure, because the amount of compute you have to do end-to-end to make AI work is gigantic and enormous. And not only do you have to do this compute once, AI is iterative. You have to keep iterating. So you have to have that infrastructure that can support these iterative computation at scale. Right? So this is a typical workflow, machine learning workflow, and I'm not going through the details, but you need to, the main takeaway here is, whether you are actually trying to predict click-through rates on the feed, or you're trying to predict the probability of someone applying to a job, the probability of someone getting the right search result, the probability of someone clicking on an ad and buying something, all of these things require a machine learning workflow so that you can implement it. And the machine learning workflow is actually an end-to-end computation. The only reason why you have multiple stages in this computation is you cannot do this computation at scale if you have to do it brute force. So you kind of divide it into different stages: offline, online, nearline. And that's where the complexity comes from. That's where you need robustness in the infrastructure so you can iterate at scale. Right? And then finally, the models and algorithms are the key to success, right? I mean, this is what you're computing. Okay? So how do we do these algorithms? So let me start with personalization. As you can imagine, personalization is a key to do proper matchmaking, right? So how do we do personalization? And this has been a journey. We started with simple models, right? Like simple model that capture macro effects using techniques, old techniques like logistic regression. And then, we went on to introduce more complexity, like using decision trees and neural networks or deep learning, which have become very popular nowadays. And finally, we actually made it even more sophisticated by using some homegrown technique, which we are calling it generalized additive model. I'm going to explain to you what that means, right? So this has been a journey, and we have really become good at this. And that's why you kind of see great results, personalized result on LinkedIn. So feature-based model, as I said, it's a combination. It is a paradigm where you capture macro effects in the model, right? So people who are in Silicon Valley tend to apply to jobs in Silicon Valley, right? I mean, that's a macro effect that you capture in your data, right? And these are things, these macro effects, there are millions of them you capture through these models, right? Neural networks, trees, and linear model, right? And although these models capture the macro effect, they sometimes miss out on the micro effects, right? So what do I mean by that, right? So like me as a user, although typically a software engineer in Silicon Valley looks for a job in Silicon Valley, I as a user, I don't follow that paradigm, right? I actually look for jobs in Colombia as well, because I have an academic background and maybe it's time for me to retire, so I'm also looking for the East Coast, right? But this is something that is not generically the case, right? And you have to capture these idiosyncrasies as well, otherwise there is no personalization. You miss out on the personalization opportunity. Similarly, there might be a CTO job, and typically if you have a CTO job in the Silicon Valley, you only see applications from Silicon Valley. But this particular CTO job also entails the person to be opening a new office somewhere else outside of Silicon Valley, and that's why you're seeing applications from other places as well. So you have to capture the macro effect as well as the micro effect and patch them up together to really have effective personalization. And that's why these models become complicated. Every user in this room will have a model with 10 or 20 unknowns. There are 600 million users on LinkedIn. Imagine the size of these models, right? And this is why this gets sophisticated and more complicated, right? Right? And so it's challenging to kind of deploy these models at scale. Right? It is easy to write it on paper, but challenging to deploy it at scale because there are many unknowns in these models. First, you have to estimate these models, and then you have to deploy them at scale in a reliable fashion, and also iterate on them. Right? So the usual approach of putting your model into the servers does not work in this case. You have to take a more scatter and gather approach where some part of the model is in the servers, some part of the servers in a key value store, some part of the servers in the index, and at runtime you have to gather everything and kind of do the computation. And that's where the complexity is coming from. Okay? So once you have these models, the lifeblood of every machine learning models are the features, as they are called, or signals that go into these models. How do we create these features? We have created what is called a feature marketplace. So every entity on LinkedIn has features that are available in this marketplace that anyone can grab and start incorporating that into the model. So you don't start from the scratch. There is some prefabrication already available in the system. Right? There are 2 billion entities on LinkedIn, almost 91 billion relationships among them. All of that is captured in this feature marketplace. Right? And how do we do that? We do that by a process that we call standardization. And roughly speaking, what this entails is you take the raw data and then you go through an AI, a human curation process, and you produce data that is standardized. So just to give you an example, there are 160 million variations of how people describe their jobs today. Some of them tell themselves, I've seen titles like data ninja, right? We take those 160 million variations and standardize them to a taxonomy of 24,000 job descriptions or titles, right? So that is what I mean by standardizing the data. You take all the unstructured text that is out there and standardize it into a taxonomy that is semantically understandable and interpretable. And once we have that, it flows through your entire downstream system and starts adding value. Right? And this is an example, right? So this is how I wrote my profile, and then you can see the standardization process kind of adding meaning to each of these segments. Okay, so based on my first text, I'm a VP of engineering, I'm a technology manager in the engineering function, and so on and so forth. Right? So you start with unstructured, and suddenly you now have a lot of structure in the data that you can now give it to downstream systems that can start interpreting that in a consistent way and add a lot of intelligence to your ecosystem. There are other ways we produce features as well. I'm not going through that, like bag of words and real-time statistics. These are all standard, and we do that as well. We have been heavily using deep learning, sophisticated deep learning method, unsupervised deep learning method as well to produce a lot of features. And just to give you an example of the sophistication we have in our system, here is a search example for our help center. And this is the model that we have created by using deep learning. And again, I'm not going through that, but there is a traditional way of doing deep learning models called CNN, convolutional neural network. There is this new amazing technique called BERT. We have productionized both of them, and actually by using the new technique called BERT, we actually get a huge boost in performance, at least for this application. We are seeing similar results in other applications as well, but BERT comes with a lot more computational complexity than CNN. So you got a lot of ROI, but you also introduced a lot of engineering complexity into your system. And again, we are not doing this for fun or any pedagogical reasons. I mean, these things do have an impact. Sophistication does add value to the business, and we have seen that consistently across all business. So speaking of sophistication, as I said, sophistication introduces a challenge in terms of engineering complexity. How do you also keep innovating as fast as you must when you have this sophistication? That's what Shouvik is going to talk about next.
Thank you, Deepak. Hello, everyone. Okay, so as Deepak mentioned, AI is omnipresent in LinkedIn and has delivered a lot of value. And he also mentioned that we have added a lot of sophistication in our models over time. We started simple, and over time we kept adding sophistication. Now, as an AI practitioner, we use the word sophistication. And when we talk to our infra partners, they cringe and say, oh, that's complexity. And that's in good days, they use the word complexity, and on bad days, they use, okay, let's not go there. Okay, so the question is, how do we solve this problem? As we add more sophistication into our products and our engineering systems, we need to have our engineering systems keep up with that. And the reason for that is what we need to accelerate innovation. A few years back, in our LinkedIn feed stack, we realized that we have added some debt, both in terms of technology and in terms of product. After that realization, we started to chip away at that. We invested in paying that debt off, and we started to see an increase in the rate at which the feed team can run experiments. Experiments are, you can think, as a proxy of innovation. And as we started to run more and more experiments, we started to drive more business value for the product. And that was sort of an aha moment that this rate at which we innovate is extremely important. So how do we look at this? How do we accelerate the velocity of innovation? I think when we thought about this, we felt that there are two aspects to it. One is the productivity, AI productivity, that is people who are working on it, how can they do their work faster? And the other side is the talent, like can we have more people working on this at the same time? To touch upon AI productivity first. So Deepak mentioned that over time we have added a lot of sophistication to this. And in order to keep up with that, the tooling and infra must stay up with the sophistication or the complexity we are adding. And it's some anecdotal evidence, like you saw that we have driven tremendous value for jobs, for example. A couple of years back, we added the deep personalization models in the job recommendation system that gave us something like 30% improvement in one shot. But over the next 6 months, we could do nothing because we have added so much complexity into the system, but our infra was lagging. So it took us time to build up on that. And given the examples we saw in the feed and the job recommendations, we felt that this is something we need to do across the board, across all the products that we have. And that led us to this project called ProML, which stands for Productive Machine Learning. It starts with a feature marketplace. As Deepak mentioned, we have a marketplace that has all the cookie-cutter features, like the profile of the member, the standardized profile, or the activities that the members are having. All those are available in a feature marketplace. So it's a wide variety of features. And along with making those features available, we have to make it available consistently across the entire stack. We have to make it available offline, where typically we use them for training models. We have to make them available in real time, where we are using them for inference purposes, and also in nearline and in all the engineering stacks. Then we have something called a Quasar DSL, which is essentially a language that we use to specify how those features are being used in a model. That's the language that we have. And the features and this language quasar, we can use those to define the model that goes into the offline systems for training the models. Once a model is trained, it gets shipped into a repository. And once a model is in the repository, we have built methods so that those models are deployed in the production systems very easily. It's like the continuous delivery and the CI/CD model for software development. So we have built the same rigor for machine learning productions as well. And finally, those models go into the inference and serving, the real-time serving mechanisms, where we run experiments and we can make inferences. We see what these models are doing online and make decisions based on that. So this is the end-to-end machine learning productivity thing that we have worked on for a little over a year now, and we're already seeing tremendous value from this. Now, the next up is the talent component of it. We have launched what is called the AI Academy at LinkedIn. We have about 400 to 450 maybe AI engineers, but we have 5,000 or more employees at LinkedIn. Now, imagine the value that we can bring if everyone at LinkedIn is conversant in AI. So that's the aim of this AI Academy. We launched this recently, and this is one of the most sought-after courses at LinkedIn. Maybe all of these people at LinkedIn will not be building models or working on AI directly, but think about it. An engineer who is writing a code to generate tracking data, if they understand how those data is going to be used, they will be able to do their job better. A salesperson who is selling a product that is built on AI, if that person understands how the AI is powering the product, they will be able to sell better. So I think that's the value that we are trying to bring through this AI Academy, and we are very excited. Now, the last pillar of our work in AI is trust as a foundation. And I think today we have seen this multiple times about the power AI has. Matt mentioned this, Kevin Scott talked about this. So we all believe that AI is a very powerful technology, and this is going to be omnipresent and is going to touch our lives in almost every possible way. And with every powerful technology, we have to be careful about how that is being implemented and what implications that will have. And sometimes we need to ask, the question should not be that what can we do with AI, but also what we should do with AI. There's a big difference between that. We take that very seriously. So LinkedIn is about the careers and productivity of members. And if we think about 5 most important categories where we should be paying special attention to, probably career of people will be there along with health and other things. So we ensure that some of the four aspects that we take very carefully are looking at what kind of bias is present in our system and whether we are taking things, the privacy of members and the security of the data and all the infrastructure properly, and also doing all of that in a transparent manner. One example that I would like to share is that of the Recruiter Search. Recruiter Search is the flagship product that many people use for LinkedIn, that is used for looking for candidates, and recruiters and hiring managers use this heavily. And what we have done there is to ensure that our recommendations that we are doing are gender neutral, in the sense that suppose a hiring manager is looking for a person in AI, and the representative population in AI is, say, 50% women and 50% men. If that's the case, then we will ensure that the results that we have are with the same proportions as well. We have touched on the make sure that there is no gender bias in this. We will be looking at others as well. Now, after all of that, quickly summarize. The first thing that I would like to mention again is that AI is like oxygen at LinkedIn. It's omnipresent. Second, AI has made huge impact at LinkedIn. And as we add more sophistication into the system, the tooling and infra has to stay up with it. And balancing these two aspects together is extremely critical. With that, thank you.